Hello. So in this video, we're going to talk about percent of increase and decrease. And just one quick example of why knowing or being able to describe a change in value or a change in numerical value through percentages is useful to us. So for example, if we had like a particular stock of a company and over time it kind of traveled this path, so we're going up in value. Now all of a sudden we're going down in value, maybe a flat line for a while, and now we're kind of working our way up. Every single one of those changes could be described in terms of percent, and it would depend on which two data points you chose. So if I wanted to know what the percent of change was from this initial value to this first peak, then I could do the calculation and, obviously I haven't labeled the axes here, but so I could just throw out anything, but I could say, hey, that's a 20% increase. That's pretty good if you're invested in that stock. And if you look online, the percent of increase and decrease are usually kept in real time based on the stock market when it's open. Okay, so let's get started. So the concept of percent of change is actually pretty straightforward, and there is a formula for it. I don't know if you would need the formula, but because you could just kind of think about what to do, but it's the amount of change divided by the original amount. That will always result in the correct percent of change. So it is a handy tool to have. So starting out with two examples with easy numbers, if we looked at 4 increased to 6, to follow this little format up here, we would find the amount of change, the difference from 4 to 6 is 2, and then we would divide that by the original amount. Well, the original amount was 4, right? And 2 divided by 4, we know that's 1/2 or 0.5, which is 50%. So this makes a lot of sense. 4 increased 50% of itself to get to 6. So think, what's half of 4? Well, half of 4 is 2. 4 increased by 50% of itself to get to 6. That's really the concept here. And so now on this example down here, what if 6 decreased to 4? Now, a common thing that some people might think is that, oh, the change is the same, it's 50%. Well, not really, because the denominator is going to be different. The amount of change is still the same, but the original number is different. So we've decreased to 4, which is a decrease of about 33 1/3%, because 2 over 6 is 1/3, right? And think about that. 2 is 1/3 of 6. So the percent of increase or decrease is really based off of your original number. That's kind of where you get the percent. Okay, let's do some examples with maybe some harder numbers real quick. Okay, so this problem reads, what is the percent of change of a stock that increased in value from $110 per share to $135 per share? And obviously I didn't give us a time frame. If this was one day, it'd be pretty awesome if you bought and sold at the right time. Good luck with that. So we want to take the amount of change and divide it by the original amount to get the percent of increase or decrease. The first thing I want us to look at is this is an increase problem because we're going up. That's pretty straightforward. So the difference between 110 and 135 is 25. So if I was to write this out long form, I'd go 135 minus 110 all over the original number, which would be 110. So it's going to result in 25 over 110. And then if you divide that out, you get a decimal. And I'm going to round this decimal because it's, a repeating. You get a decimal that looks like this. And of course, to turn a decimal into a percent, we can move the decimal place to the right twice or multiply it by 100. Because see, this right here, this decimal, this is 22.7 hundredths. And percent means hundredths. So we could say that's the same thing as 22.7%. So an increase of 22.7% is pretty good. That means if you take 22.7% of 110, that's going to be right about 25. And that was our increase. Let's do one more example here. So you might be asked to solve some problems like this, where you're given the percent of increase or decrease and asked what the other number is. So this problem reads, a business last year was valued at $35,000. Since that time, it has experienced a 15% decrease in value. That's not good, right? What is its current value? And I don't want us to be stuck in like this formula mode, right? That thing I showed you before where the amount of change was divided by the original value, that's just a handy way to go straight to the percent of increase or decrease, right? Well, in this case, there's a lot of different ways to solve this problem. There's a lot of different ways to solve all these problems. So I'll just show you some of my favorite ways. So logically, I need to know what 15% of 35,000 is so I can take that away from 35,000. So as you guys know, to find the percent of any number, you can turn that percent into a decimal. 1500ths and 15% are the same thing. And then you would want to multiply that by the number. So I believe that 15% of 35,000 is 5,250. I've got a calculator in front of me. And so I need to subtract that from 35,000. So 35,000 minus 5,250. And let's see, I got 0. Now I got to borrow from the 5. So that becomes a 4, 9, and that will be a 10, right? I hope I did that right. 5, 7, got to borrow again. 9, 2. And that seems to make sense. $29,750. So that would be what our current value is straight away. Now there's another way to do this that I find is much easier, especially if you're working with Excel or something and you're working with percentages. The least amount of steps is nice, right? So we can just do we can basically do our subtraction first. I guess it's not a lesser amount of steps. It's just the order in which you do it. We can say, hey, if we wanted to know what 15% off of 35,000 is, that's the same thing as 85% of 35,000. So instead of figuring out what 15% of 35,000 is and then subtracting that, what I can do is I can say, okay, if I did 1 times 35,000, it would be 35,000, right? Because 1 is like 100%. So if I just did, okay, 1 minus 15%, that's going to result in 85% or 8,500ths. So if I just multiply 35,000 by 8,500ths, I get the same number. So that might be another quicker way for you to go about problems like this. Thanks for watching, and good luck to you. Try to do those problems I listed there on the website, or don't try, do it, and I'll see you guys in class.